Greetings all, now on with more statistics. Central tendency. Oh, look at that. Forgot to put my fly-throughs in. Not to worry, this is pretty simple stuff. Central tendency is a term that we use to describe three processes, essentially, typically three processes, or three statistics that we use in the descriptive world. All right. So at the most basic and saying it in an advanced way, we're saying that a measure of central tendency is a simple model that represents your data. So for example, the mean is a model that represents your data. The median is a mode, so on and so forth, and we'll talk about all those. It's derived directly from the data, right? And so it's not created willy-nilly, it's actually came directly from your data, and it can represent it well or not. Right. So sometimes the median is the best representation of the data, sometimes the mean is, sometimes the mode is. It all depends on what type of data you have. So let's look at the most common one that you run into, which is the mean. Okay. Again, this is sum all the data points up, divide by the number of data points. That's what that fancy equation says. So x bar, whenever you see x bar, that's the mean. Right? You don't write a big capital M, that's something else. I don't know what the hell it is, but it's definitely not the mean. And it equals the sum, is sigma, right? So this little guy right there. So sigma, sum of all the x's divided by n. N is the sample size. Now, really I should have used a smaller case n there, but it doesn't really matter for the points of this course. Smaller case n denotes the sample size, or the size of your sample. Large case n denotes the size of your population. So oh well, no biggie, you get the same idea. So this is just how you represent the typical arithmetic average, right? The problem with the mean is that it is sensitive to extreme scores. So imagine if we did average home prices in the state of Washington. Those homes that are $10 million, 15, 20, 30, so on million dollars are going to drive up the average prices, right? So they're going to drive up that average price. So that's actually not a good tool to represent all of the data. It's not a good model that will represent the data well. We should probably use something else. It requires ordinal level data, or ordinal, interval, or ratio level data. All right? And keep in mind, probably the most important point that I like to make about the mean is it represents a sample, not a person. Very rarely, you can get a mean of which no one in your sample, or if you generalize it to the population, no one will fall at that mean. Imagine that, think about the averagers, 2.54 children per family in the United States. What in the world is a 0.54 child? It doesn't exist, right? You can't do that. So that's one of the other problems with the mean, and that's a problem with statistics in general applied to the individual level, but we'll deal with that as we go on in the quarter. So again, remember, it applies to a sample, not to an individual. There may be individuals that fall at the mean, there may not. But that's all you can say about an individual in the mean. It doesn't predict one person's performance. It's saying that on average, this was the score that the group produced. Okay. All right, the median. Lots of numbers here. Don't worry about it too much. All right, let's just focus on each one. So this is the halfway point in your data. Right? 50% of the scores fall above, 50% fall below. It's completely insensitive to extreme scores, as you will see. So when you have these major outliers, we tend to use the median as a representation of the data. So the number in blue is the median for each data set, so you can see all those things. If you just count the numbers of data, or the numbers that are there, then you'll see that exactly half the numbers are on top and half the numbers are below, and that one's dead center. Okay. What was I going to say? Obviously you need to put them in order to find the median. It can be a bit challenging if you don't do that, as you may have experienced on the Khan Academy already. I was playing around with it, trying to come up with the median the other day, and doing the box and whisker plots and things, and I was trying to do it without putting it in order, and my gosh, it was a challenge, but I wasn't able to do it. I eventually had to just put the darn numbers in order to make it happen. So when you put the numbers in order, then it's easy. Just count how many you have and find the middle point, right? So, and notice here that the data sets are identical until we get out to the end, right? Now you've got a 23 here and a 2,103 here, but notice the median didn't change at all. If we were using the average here, that average would have been driven way up, way over on this end of the scale because of that 2,103. And that's why we don't use the average when you have these big outliers. If you have an even number of these buggers, then what happens is that the median will fall in between two data points, right? So in between a 7 and an 8, what's the arithmetic average of that? It's 7.5. So that's how we end up with that one. The mode, this is simply stated, the most frequent, right? The most frequent response, the most frequent score. It works with any type of data, but it's typically used for the nominal situations, right? So, you know, how many people in the class have blue eyes or green eyes, or how many people are Pacific Islander or African American or whatever. The idea is that all we're doing is getting a count. Right? And with this, sometimes you'll get a bimodal distribution, and a bimodal distribution shows you when you have two modes, two scores that are equally occur with equal frequency. That can give you some additional information. It tends to push you into a different type of category for statistical analysis. And one of the things that you're going to see here in the future is that when the mean, median, and mode all line up on the same spot, that's called something special. It's called a normal distribution. So the next time we talk about stats, we'll start talking about just measures of dispersion and spread, and how we can assess the accuracy of that mean, and then we'll also eventually start talking about normal distributions. I told you this would be a quick one. Have a good time. See ya.